My name is Lavanya Vats and the date today is 4th October 2025. I'm going to be explaining about a chiral compound called ibuprofen. So we're going to talk about ibuprofen. Like I already said, we'll start with the structure. This right here is the structure of ibuprofen. The IUPAC name is 2,4,2-methyl propyl phenyl propanoic acid. The common name it is known as is ibuprofen. The functional groups present in ibuprofen are: first is the carboxylic acid, which is the COOH group. It is very crucial for its biological activity. Next is the aromatic benzene ring or group in the center, which is typical for many of the pharmaceutical compounds you'll find. And the third one is an isobutyl side chain that is attached to the benzene ring, and it is responsible for adding bulk and influencing how it interacts with the body. So now ibuprofen is chiral. That means it has a carbon atom with 4 different groups attached, which creates a mirror image or enantiomers, you can say. The chiral center is the carbon on the propanoic acid side, and this carbon is attached to: first is the carboxylic acid, next is the aromatic benzene ring, which is substituted with an isobutyl group, third is a methyl group, and then the fourth one is a hydrogen atom. And now if we talk about priorities, priority list goes from carboxylic acid getting the highest priority, then the aromatic ring, and then the methyl group, and lastly the hydrogen atom. Now the stereochemistry of ibuprofen is determined by all of the sequence of the functional groups present in the structure other than hydrogen, of course, so the first 3. And the sequence of that determines the stereochemistry of ibuprofen. If the sequence is clockwise, then the center is R, and then if the sequence is counterclockwise, the center is considered to be S. Now all of the ibuprofen tablets or medicines sold at pharmacies are made into a racemic mixture, which is a 50-50 mixture of 2 non-superimposable mirror images molecule. Alright, so that is a racemic mixture, but even in that racemic mixture, only the S enantiomer is effective at blocking pain. Now enantiomers, the 2 enantiomers of ibuprofen are R enantiomer and S enantiomer. There are no diastereomers because it only has one chiral center, and the constitutional isomers can be any other phenyl propanoic acids with different substituents. Here we have our isobutyl group as the substituent, but if you replace that with any other substituent, that will be considered as a constitutional isomer of ibuprofen. The common uses of ibuprofen are pain relief, fever reduction, and inflammation. And the mechanism or how it usually works is it acts by inhibiting the cyclooxygenase enzymes in the body, which in turn blocks the prostaglandin production, which is responsible or mainly involved in the pain and swelling that we get.